So I'm just going to get right to it. I don't want to drag this out. I've taught this lesson before using discovery learning. And if you don't know what that is, it's where you kind of present something and then let the kids discover the connection on their own. It's really not necessary in a case like this to do that. So I'm just going to put one up here. By the way, today's the 7th. And you are going to be learning today vertex form of a quadratic. And I know I don't think I say it enough. What you've been doing, I need to say this out loud so that we can start getting this in our heads. Everything you've been given in the last few days has been standard form. So a standard form of a quadratic is the ax squared plus bx plus c, like what we would have it as if we were going to do like the quadratic formula or factor it or something like that. So that's what you're accustomed to up to this point in time is standard form. And standard form by now, you're relatively good at it. You get the idea, find A, find B, blah, blah, blah. But what we're going to work with today is a totally separate form of a quadratic equation or a quadratic function called vertex form. And you probably already know this, but I'm going to say this out loud. It's called vertex form because it gives you the vertex. There, I said it. So if I put an equation like this, you can graph it super fast. And there is no A, B. I mean, there is, but it's been bundled in a way that will make way more sense tomorrow. I'm not going down this road today. I'm going to resist the urge to be the kid in the candy store and start geeking out on this. This is a standard form quadratic that has been modified to look better. And it's better because the vertex it comes to you on a silver platter. And I can already tell you from looking at this, you know how it is with standard, how we got to do negative b over 2a and go through all that. It takes time, right? It's like a chore. I can already tell you that the vertex of this parabola is guaranteed at the point 4, 3. It just comes right out of the function. Let me give you another one here. I can tell you if we had this, that this one has a vertex at -2, -1, right? We could do this all day. The vertex just plops right out. When you have a quadratic equation that has been written in its factored form like this, the vertex is right there. Boom. No A, no B, no math. So you'll notice, of course, that, and you've seen this idea before, like this isn't the first time we've had this idea of if I see x plus 5, my answer is -5, right? You saw that when we solved quadratics by factoring, that when you want to make something equal 0, then you take the opposite of what you see. So like if I said to you, what makes that yellow oval equal 0, what goes right there? +4. And that's why the vertex has an x coordinate of +4. All right, you'll remember it just has changed the sign, and that's fine. But for the one in the parentheses, the argument part of the function, this is the meat and potatoes part of a function where the variable's at is called the argument. If you tinker with the argument, that's the one where you go backwards, and the one at the end is just an afterthought. It's a vertical. It's a simple shifter. So notice that with the 3 at the end, I did not change it. +3 means what it means, of 3. Okay. The -2/3 has nothing to do with the vertex. Right, it's your builder. So all the stuff that's the directions to the build site is everything but the number in front. And that number in front, I got good news, is going to behave just like he always has. He's still, and again, I'm avoiding the urge to do this, but if you were to take x plus 2 squared, let me draw like a red box around it for you. If you were to actually do that math problem, just FYI, I'm very quickly, not going to go deep, it would get x squared plus 4x plus 4, right? Like we've done that before. And if you took that and distributed the -2/3, you'd have a standard form parabola, right? But look at what A still is. A is still -2/3, right? So when we're finding the vertex, this number, I'm going to go ahead and go vandalism mode on you here. This number has no significance on finding the vertex itself. The vertex comes from the argument and the afterthought number. We good? So once we get to the vertex, that's the directions, and then we go and we follow the builder number just like we always have, and that is that. So let's do a couple practice. Okay. If I give it to you in Vertex, the Vertex is, I mean, that saves you 3-4 minutes just right off the top. You don't have to do anything. All you got to do is make the graph. Okay, let's do it. Is this making any sense so far? Yeah. Wunderbar. So let me throw in some axes for you here, and let's make a graph. As always, the most difficult challenge will be the actual making of the graph to not look like poo-poo, right? It's always the hard part. So let's say we had a function, we'll call it f of x, y equals whatever. Let's do -2 times x plus 3 squared plus 5. You right away, if I'm any good at this and you're any good at this and we're a good team at this, you right away recognize the vertex is at -3, +5. Good. So it's nice. It pops right out for us. So the vertex is at the point -3, +5. Remember, change your x, don't change your back number. So I'm going to go to that point. I'm going to go to left 3, up 5, 1, 2, 3, 1, 2, 3, 4, 5, and boom, there's my vertex. Now finding the other points is, I'm at the point now, and because I'm recording this, I can do this. Because if someone said, oh, wait, I didn't write that down, and they're taking notes at home, they can just hit the rewind button. I'm at the point in this problem where I could just do this now. I don't need anything anymore other than the number that is the builder, and he's still the front guy. He's still out in the same spot. So what does a leader of -2 tell me about my function? Like how? Right. So so like when I go out 1, I go down 2, right? That shouldn't be news to you, right? When I go out 2, how far down will I go? 8, down 4, 1, 2, 3, 4. Because I'm just taking all my normals, my 149s, and I'm just doubling. So the builder number behaves exactly the same as he always has. And that's how quick you can graph in vertex form. You just plop the vertex out and then use the number in front. Easy peasy. Got it? Easy? One more? Couple more maybe? I don't know. How about this one? I'll change the notation this time back to y. So let's do y equals 1/3 times x minus 4 squared.
It would be.
And you might think that you might think I forgot the rest, right? Kinsley's on top of things these days. She knows that if there's no number, it's of course implied or assumed to be a 0. So the vertex I can find right away is at the point 4, 0. And if you wanted to put something here that would, validate that, here it goes. That makes you feel better, right? Put a 0 there. Down with your bad self. But the absence of that number is a number, right? It's a 0. So I go to my vertex of 4, 0, which of course is right 4, up or down 0. And does the graph open up or down?
Up.
Up at a rate of
1/3.
1/3. So when I go out 1, how far up will I go?
1/3.
1/3 of the way to 1. This is looking new. It's because you haven't done enough of assignment 37. I assure you of that. If I go out 2, how far up do I go?
1/3 of 4.
1/3 of 4. It's not a bad thing to say. What the heck is 1/3 of 4? Remember, it's just 4/3, which is 1 1/3. So when I go out 2, I go up 1 1/3 of the way to 2. Right? The modifier is driving the ship here, right? When I go out 3, how far up will I go? Nope.
No,
3. I will take my normal. Remember, if you go out 3, under normal circumstances, you would go up 9. But the 1/3 in the front tells me to take 1/3 of all the what you would do's. So 1/3 of 9 is 3. So when I go out 3, I actually go up 3. So 1, 2, 3, 1, 2, 3. That's it. Keep going, obviously, but that's the gist.
absolutely.
That's what vertex form is. And if that doesn't seem easy to you, I would feel like, man, I need to do better. Like, get good, Mr. A, you knew, but this is ridiculous. That should be one of the easiest things we ever talk about. And its simplicity is, of course, again, based on prior work. And that is that you now know how to work with this number in front. We're not scared of that anymore. If it says like 3/4, we know to just take 3/4 of all the normals, right? You get it. But it's finding the vertex. That's huge. You got to admit, finding the vertex is a lion's share of the work on those standard form ones. And if you take that out of the equation, now it's just build, 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 easy peasy. So I got a worksheet for you. It's got, I don't know, 12 problems, I think, 6 on the front, 6 on the back. Shouldn't take long. Get her done. Any questions? I'll leave the recording going because there might be some, you know how it is. There might be something where I go, oh, I forgot to say that. So I'll just leave it going just in case. But short and sweet.